This video lesson is going to talk about the vertex form of a quadratic function and how to write the equation of a quadratic function if you've been given the vertex or some information about points that live on the parabola itself. A couple important things that you needed to notice here. I'm going to add a highlighter in here. In the parentheses here with x minus h, the value of h is the x value for our vertex. It also represents our axis of symmetry. But if you notice, going from my vertex form to the actual vertex point, it's the opposite sign of h. So if this said x minus 2, my vertex would have a value of 2 for the axis of symmetry. If it said x plus 2, then my vertex and my axis of symmetry would involve the value of negative 2 for x. So the first one we're going to look at is writing the quadratic equation for a parabola that has a vertex of positive 3, positive 2 that passes through the point of 1, 1. So what I need to use is the vertex formula, or the vertex form of a quadratic function, and I'm going to figure out that what 3 and 2 represent and what 1, 1 is going to represent. So since this 3, 2 is the vertex, 3 is going to be our value for h, 2 is going to be our value for k, and then 1, 1, since that's a point that lives on our parabola, this is going to represent x and y. So if you look at vertex form, it says y equals a times x minus h squared plus k. Since I don't know this value for a here, that's my ultimate goal so that I can successfully write this quadratic equation. So I'm going to start by substituting in all of the information I know and use that to find the value of a. So 1 is the value for x. I don't know what a is. X is also 1. H is positive 3, so I'm going to write that as negative 3 in my equation, and then plus 2 for my k value. So I'm going to subtract 2 and start to simplify these parentheses at the same time. So 1 minus 2 gives me negative 1. If I could actually write. So 1 minus 3 is negative 2. Negative 2 squared gives us a value of 4. So I'm going to have a times 4. Dividing by 4 to get a by itself, I'll have that the value of a is negative 1/4. So this a value and the vertex is what's going to actually go into my quadratic equation for our vertex form. So I'm going to have y equals negative 1/4, which is my a value, times x minus 3 out of our vertex squared plus 2. And this is the vertex form of the quadratic equation that has a vertex of 3, 2 that will also pass through the point of 1, 1. We're going to do 1 or 2 more examples like this so that you can successfully write the quadratic function for your catapult. So now I've given you a vertex of negative 2, positive 5. So this is h and k. And now I have a y-intercept of 3. I'm going to write that as a coordinate point so that I can use it as x and y. Since it's a y-intercept, I know my x value is 0, and my y value will be 3. So I'm going to use this as x and y. I'm going to substitute that into my equation. So I have 3 equals a, which I don't know. X is actually 0 because I'm solving the equation right now. And since my value for h is negative, I'm actually going to substitute that into my equation as plus 2. And that whole thing's going to be squared plus 5. So like I did on the last one, I'm going to do a couple steps at a time. So I'm going to subtract 5. So 3 minus 5 is negative 2. I still don't know a. 0 plus 2 gives me 2. Squared gives me a value of 4. If I divide by 4, I would have negative 2 over 4, which simplifies to a value of negative 1/2. I'm going to go back and substitute everything into vertex form. So I'll have negative 1/2 times x plus 2 squared plus 5. And that will be the quadratic equation for this parabola. One more thing we're going to look at. If I can get the slide to move. So now I've given you x-intercepts and a minimum. Since I've got a minimum, if I think about what this would look like on my graph with a pen, so I'm going to draw the x and y axis. So I've got negative 12, 0, which is down here somewhere, we'll say. And I also have negative 4, 0, so we're going to put that here. Negative 4, 0. And I have a minimum of negative 16. That tells me about my vertex. This is the y coordinate of our vertex. Oops, I didn't mean to do that. So what I need to figure out now is the x value of my vertex. So down here, I'm going to have an, goodness gracious, I'm going to have a y value of negative 16. And my job is to figure out what the x value is going to be. There's a couple ways that you can do this. You can always use the midpoint formula between negative 12 and negative 4. Figure out what the midpoint is between those. You can figure out the distance between the values of negative 12 and negative 4 and figure out how many units away those two numbers are. But either way, regardless of how you do it, you need to figure out what this middle x value is between negative 12 and negative 4, because that is the x value that I need for my vertex. So if you do the midpoint formula, I'm going to have negative 12 plus negative 4 all divided by 2. And that's going to give me negative 16 divided by 2, which is going to give me a negative 8. Wow, that doesn't look like an 8. Let's just pretend that that looks like an 8. So I'm going to have negative 8, negative 16 as my vertex for this quadratic. Now from here, I'm doing the exact same thing that I did on the last problem. I have a vertex of negative 8, negative 16, and I've got two coordinate points that I can choose from now, my x-intercepts. It does not matter which x-intercept you choose to write the equation with. So let's use negative 4, 0. So I'm going to say that my y value is 0, and that's going to be equal to whatever a is multiplied by negative 4, because that's my x value. And then I have negative 8 as the x value of my vertex, but I need to think of doing the opposite. So that's really going to be plus 8 squared minus 16. So negative 4 plus 8 gives me a value of 4. If I square that, it'll be 16. I'm going to add 16 to the other side. So when I add 16 to the other side, this is going to be positive 16 equals a times 16, which tells me that the value of a has to be equal to 1. So my equation is going to be y equals x plus 8 squared minus 16. And that is the equation with a minimum of 16 and my x-intercepts of negative 12, 0 and negative 4, 0. And the question that I'm going to leave you with so that we're prepared for catapults tomorrow is figuring out how the vertex and the maximum distance of your catapult are related. So if you think of this is the ground, pretending that I can draw a straight line. Here's my catapult. How is this distance to get to the maximum distance and this vertex point? What's the relationship? And that's your mission for class tomorrow.